To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all some extra questions related to household electric circuits, or what we call as home electric circuits or domestic electric circuits. So in the lesson we discussed what power is. Now you all know there are many different electric appliances which use electricity and that is converted to different forms of energy. There is the work done in a unit time, or the electricity consumed in a unit time, the energy consumed in a unit time is the power of that particular appliance. Then we discuss the amount of electric energy consumed by each device, and from there we discuss the efficiency of different electrical appliances that are used for the same purpose. And thereafter we discuss the household electric circuit, the components that are present in the household electric circuit. You all can remember from the distribution wire, then we have the supply cable, then the service fuse, then you have the electricity meter, after that the isolator, the trip switch, the distribution box, the MCBs that are present there, and also what consumer units are, as well as the plug circuit and the lamp circuit, including the light bulbs and the plugs. We discussed the types of wires, different types of plug sockets, and all those came under household electric circuit. And you all know the protective measures that has to be considered or practiced when you use electricity in your households, so that you can prevent accidents due to electricity. So finally, we discussed the number of units that is consumed by the consumer, that is in kilowatt hours, electric energy consumed by the consumer, how to calculate that and how to calculate the amount of the electricity bill based on the consumption. So those were the concepts discussed in the lesson. Then in the previous chapter, I discussed the questions given in your textbook. Now I am going to discuss some extra questions with you all. And here, extra question 1. So now that you are familiar with these types of questions, the MCQ or the multiple choice questions, where you have to select the most suitable answer. Select the most suitable answer. In that, first one, a current of 2.5 amperes flows through a filament bulb when the voltage difference across the bulb is 5 volts. So you are given the voltage 5 volts and the current 2.5 amperes. What is the power of the bulb? So what is power? Power is the work done in a unit time, or the electric energy consumed in a unit time. So when you supply a voltage difference across an electrical appliance and there is current being drawn by the appliance, the power is equal to voltage into current. So for that we have the equation P equals V into I. So we have both the quantities. What is V? 5 volts. And current I is 2.5 amperes. So when you multiply that, you get the answer as 12.5. What is the unit? Voltage into amperes, you get the answer in watts. Watts. 5 into 2.5, so you have the value as 12.5 watts. That is the power of the bulb. So if we look at the answers, you can see 12.5 joules, that is energy. Joules is energy. 12.5 watts, that is correct. 0.5 watts, 2 watts, those are incorrect. So the answer is 12.5 watts. A current of 2.5 amperes flows through a filament bulb when the voltage difference across the bulb is 5 volts. And what is the power of the bulb? You use this equation, P equals VI, 5 into 2.5, so that is 12.5 watts. Then, the next question. Question number 2. Kilowatt hour is used to measure. What is watts? Power. Now, power, normally to convert it to energy, you need to multiply by time. There you will get the energy in joules. You can remember that. If we multiply power into time, you will get energy, and that will be in joules. But the thing is, when you consume a very large amount of electric energy, this value will be very high. You can remember that. We have done calculation related to that. So, because of that, what we do is, as a commercial unit, we use kilowatt hours. So, we have to have the power in watts and the time in hours, and power also in kilowatts. So, when you have watts, you divide it by 1000 to get kilowatts, and hour, the time has to be converted to hours, or it has to be in the unit hours. So, kilowatt hours is used to measure the number of units of electric energy consumed by the consumer. So, the first answer is electric energy. That is correct. If it is work, it will be in joules. Work will be in joules. Work, energy, both are going to be in joules. Power is in watts, and heat again is energy. So, that is also going to be in joules. So, kilowatt hour is used to measure electric energy. That is the answer. I am sure you were also able to answer these questions. So, with that, students, we will move on to the next slide. Extra question 1, under that the third one. Component of the domestic electric circuit that does not belong to the consumer. Now, you all can remember from the national grid, power goes to the distribution sub-centers. From there, using the distribution wire, power, electricity is supplied to the household. So, from the distribution wire, you have the supply cable. Supply cable is connected to the first component, that is the service fuse. So, service fuse is a component that actually belongs to the distributor, not the consumer. Then after the service fuse, what do we have? We have the electricity meter. So, those are two components that do not belong to the consumer. Both of them belong to the service provider. From the isolator, that is the main switch with the main fuse, all the other components belong to the consumer. So, here the question is component of the domestic electric circuit that does not belong to the consumer. So, here distribution box. Distribution box contains the MCBs, miniature circuit breakers. Using the distribution box only, current is supplied, electricity is supplied to different parts of the household. So, that belongs to the consumer. Then we have the electricity meter. That belongs to the service provider. So, that does not belong to the consumer. Look at the question. Does not belong to the consumer. So, electricity meter does not belong to the consumer. Then isolator. Isolator, main switch with the main fuse. Starting from the isolator only, everything belongs to the consumer. Trip switch, RCCB, residual current circuit breaker, that also belongs to the consumer. So, only component that does not belong to the consumer is the electricity meter. Then, the least efficient light bulb based on power consumption and lifetime. Here you have to see least efficient. That's very important. So, in these light bulbs, what happens? Electricity is converted to light energy. So, all of them are used for the same purpose, to light the area, light up the area. So, there, what are the two things we consider? One thing is the power consumption. If the power consumption is high, efficiency is less. And also the lifetime. If the lifetime is less, efficiency is less. So, here we need to find the least efficient bulb. So, there we need to consider the bulb that has high power consumption high power consumption and short lifespan, short lifetime. So if you consider all the bulbs, normally filament bulb, that is the tungsten bulb that was used for a long, that has been in use for a very, very long time. But now the use of filament bulbs is decreasing. Why? That is the bulb that takes up very high amount of electric power and also it has a short lifespan. Then after that, the fluorescent bulbs. Normally the tube bulbs, fluorescent tube bulbs or what we call as tube lights. Compared to filament bulbs, they consume less power, but their lifetime is also slightly more than the filament bulbs. Then we have the CFL bulbs, the compact fluorescent lights. Similar to fluorescent lights, but they are compact because based on their shape, the size is less compact. So that has a lesser power consumption and a higher lifetime compared to filament and fluorescent bulbs. Then the most efficient one, that is the LED lights, light emitting diode lights. So these are the most efficient ones. They consume very less power, that is 6 to 8 watts, and also their lifetime is very long, about 50,000 hours. Very much high compared to filament bulbs. So you know the order of efficiency, increasing order of efficiency as well as increasing order of lifespan. For lowest is the filament bulb, then it is the fluorescent bulb, then you have the CFL bulb, and the most efficient is the LED bulb. So here the question is the least efficient light bulb based on power consumption and lifetime. It has to be filament bulb. So if you look at the answers, fluorescent bulb, LED, filament bulb and CFL. So out of that, it should be the filament bulb. I'm sure you can remember that. So with that, students, we'll move on to the next slide. Question number 5. Consider the statements regarding residual current circuit breakers, RCCB, or what you call as the trip switch. Residual current circuit breakers, RCCB. Statement A, the purpose of connecting to a RCCB is to protect the residents from electric shocks. That is correct, because you all know, now in the earlier electric appliances, the metal casing is there. So sometimes there is a possibility of electricity leakage to the metal casing. But the metal casing is connected to an earth wire, and that is earthed. At the same time, it is connected to the RCCB or the trip switch. So what will happen when there is an electricity flowing into the electricity leak to the metal carrying or the metal covering of an electrical appliance? Immediately, due to electromagnetic induction, there will be a current flow to the RCCB, that is the trip switch. So because of that, the trip switch will cut off the power supply to the household. The lever will move down and it will cut off the power supply to the household. So that is how the RCCB or the trip switch functions. So it protects the residents from electric shocks. That's correct. Statement B. Condition of the trip switch can be tested using the test button present in it. That is also correct. There is a test button which you can press. When you press it, automatically the lever of the trip switch comes down and the electricity to the household will be cut off, disconnected. So that is to test and see whether the trip switch is working properly. So this has to be actually done periodically. Every few days you have to actually test it. So that statement is also correct. If we look at the answers, the only A is true. No, both A and B are true. Second one, only B is true. Third one, both A and B are true. And fourth one, both A and B are false. So the correct answer is both A and B are true. That is the correct answer. Then we have the next one. Sixth one, select the incorrect statement. So here incorrect statement regarding trip switch. That is also regarding trip switch. RCCB or residual current circuit breaker. Now we discuss the function. It is used to protect the residents from electric shocks. That is correct. It is a dual pole switch. That is also correct. What is the meaning of a dual pole switch? Now when the trip switch disconnects the power supply, it disconnects both the live and neutral wires. So the trip switch is connected to both live and neutral wires, and both the wires are disconnected. Power, current supply, electricity supply to both live and neutral wires are disconnected. Such a switch is known as dual pole switch. Dual means two. So both live and neutral wires are disconnected. So that is also correct. It is a dual pole switch. Then the third one. The switch can be turned off using the test button. That is also correct, no? You can turn it off using the test button. When you press the test button, it has to turn off and the power supply, electricity supply to the household should be cut off. That is also correct. Then the last one. Both the live and neutral wires from the electricity meter are connected to the trip switch. Is that correct? Now both live and neutral wires are connected. That is correct. That's why it's a dual pole switch. But if you remember the order of the components, initially we have the service fuse, then we have the electricity meter, then we have the isolator. From the electricity meter, live and neutral wires are connected to the isolator. After the isolator only, we have the trip switch or the RCCB. So that is the reason this statement is incorrect. So both the live and neutral wires from the electricity meter are connected to the trip switch. That is incorrect. Because after the electricity meter, it is the isolator. Only after the isolator, we have the trip switch or the residual current circuit breaker. So those are both related to trip switch or RCCB. With that, I will move on to the next slide. Question number 7. Electricity supply to the whole household can be disconnected by turning off there are different components that can be used to turn off the electricity supply to the whole household. What are they? One thing, overload circuit breaker or the service fuse that belongs to the service provider. You can turn that off. There is a lever. If you bring the lever down, pull the lever down, it will disconnect the electricity supply to the household. Then we have the isolator. Isolator is the main switch having the main fuse. That also can be used to turn off the power supply to the whole household. Again, you pull the lever down, then it is off. Then we have the third component, the trip switch or the RCCB, residual current circuit breaker. So that also can be used to turn off the electricity supply to the household. So there are three components, overload circuit breaker or the service fuse. Then we have the main switch with the main fuse, that is the isolator, and then the trip switch, that is the residual current circuit breaker, RCCB. So let's look at the answers. Switch can only be used to switch on and off a particular electrical appliance. Maybe a light bulb, a fan, an electrical device connected to the plug. So only one component can be turned on and off. Then miniature circuit breakers, MCB, what is the function? MCBs are present inside the distribution box, and from the distribution box, electricity is supplied to different parts of the household. So if there is a problem, if there is excess current flowing through that particular part of the circuit, miniature circuit breaker will cut off the power supply, electricity supply to that part of the house only, not the whole household. only to a part of the household, electricity supply will be cut off by the miniature circuit breaker or the MCB. Then we have the isolator. Yes, isolator we said will cut off the power supply to the whole household. So that is the main switch with the main fuse. And also when there is current more than 30 ampere being supplied to the household also, it will turn off the electricity supply. But you can use that to disconnect the electricity supply to the whole household. Then electricity meter, it only has a record. It just measures or monitors the amount of electricity consumed by the consumer. So the component that can disconnect electricity supply to the whole household is the isolator. It is the isolator. You have to remember that. Then the 8th one. The conducting wire identified by the green color cover. Now look at the color. There are 3 colors. If you remember, live wire, brown color. Neutral wire, blue color. And the green color is earth wire. There are 3 wires, conducting wires, copper wires covered by a PVC insulator cover. So that has different colors used to identify them. So you know brown is live, blue is neutral and green is earth. In the early days, they used red for live wire and black for neutral wire. But now it is brown for live wire, blue for neutral wire and green for earth wire. So the answers, live wire, neutral wire, earth wire, none of the above. So it has to be earth wire. The conducting wire identified by the green color cover is the earth wire. So with that, I'll move on to the next slide. So extra question 1 under that question number 9. The 9th question. Power of an electric appliance is P. The current flow through it is I and the potential difference across the device is V. The correct relationship among these quantities is between these 3 quantities: power, potential difference and current. What is the relationship? P equals VI. You all know the relationship. Power is equal to voltage into current. That is P equals VI. Now you all know power is the work done in a unit time or electric energy consumed in a unit time. And that is given by voltage into current. When you have an electrical appliance working, it will be drawing current and there will be a potential difference across the electrical appliance and that is the voltage. So power is given by voltage into current. That is the equation you all have used for calculations. So here, the correct relationship V equals PI is incorrect. P equals V divided by I, that is also incorrect. Third one, P equals VI, that is correct. And the fourth one, P equals I divided by V, that is also incorrect. So the correct answer is the third one. The correct relationship between power, voltage and current, P equals VI. Then the next question. Now the correct order of components of the household electric circuit. So it has to be the correct order of components. Now can you remember the components? Initially from the distribution subcenters, electricity is supplied by power supply cables and from there to the household it is the supply cable. Before that, the distribution wire, we have the distribution wire and then the supply cable. So from the supply cable, initially electricity is supplied to the overload circuit breaker or the service fuse. Then from there, it is the electricity meter. Then after the electricity meter, we have the isolator. After the isolator, it is the RCCB, residual current circuit breaker or the trip switch. and thereafter distribution box containing the MCBs, miniature circuit breakers. Then you have the different components. So that is the order. So let's look at the answers. First one, overload circuit breaker, then electricity meter, isolator, residual current circuit breaker. That is of course correct, the correct order. Then second one, electricity meter is first. Then you get overload circuit breaker, that's incorrect. Isolator and residual current circuit breaker, so it's incorrect. Then the third one, again electricity meter, overload circuit breaker, residual current circuit breaker and isolator. That is anyway incorrect. And the fourth one, residual current circuit breaker. That is the fourth component. Overload circuit breaker, electricity meter and isolator. So the second, third and fourth answers, the order is incorrect. Only the first one is correct. Overload circuit breaker, electricity meter, isolator and residual current circuit breaker. So overload circuit breaker is the service fuse. Electricity meter, isolator is the main switch with the main fuse, and residual current circuit breaker, that is RCCB, that is the trip switch. So that is the correct order of components of the household electric circuit. You have to remember them, students. You have to know the components and you need to know their functions as well. So with that, we'll move on to the next question. So here, question number 11. Energy in joules equal to 1 kilowatt hour. So energy in joules equal to 1 kilowatt hour. So how do we find that? Now 1 kilowatt hour has to be converted to watts, and for joules the time has to be in seconds. So what do we need to do? We need to multiply 1 by 1000. So it becomes watts, and time also 1 hour into 60 seconds. 1 hour we need to convert it to seconds. So if you multiply all that, you will get the answer as this. So here we have 3,600,000 joules, or that can be written as 3.6 into 10 to the power of 3.6 into 10 to the power of 6 joules. So that is another way of writing it. 3.6 into 10 to the power of 6 joules. So if we look at the answers, the first one, 3.6 into 10 to the power of 6 joules, that is correct. 3.6 into 10 to the power of 5 joules, 3.6 into 10 to the power of 7 joules, 3.6 into 10 to the power of 4 joules, all the 10 to the power values are incorrect. So the correct answer is 3.6 into 10 to the power of 6 joules. So you have to remember, students, as a commercial unit we use 1 kilowatt hour. You can understand why. Now if it has to be 3,600,000, it is a very large value. Now 3.6 into 10 to the power of 6 joules is a very large value, especially when you consider the amount of electricity you consume in a month. So that is why they use this 1 kilowatt hour as one unit of electric energy consumed by the household. But you should know the conversion. From kilowatt hours to convert to joules, you have to first convert it to watts by multiplying by 1000, and also you need to convert hours to second. Hours to minutes you multiply by 60, minutes to seconds you multiply again by 60. So 60 into 60 seconds. You will get the answer in joules. Watt seconds is equal to joules. I am sure you will remember that, because energy equals power into time. So we have got the answer. Then the next question. Component that protects the residents from electric shock. Component that protects the residents from electric shock. What is it? It is the trip switch, the RCCB, that is the RCCB or the residual current circuit breaker. Everything referred to the same component. RCCB, residual current circuit breaker, or another name, trip switch. So how does this function? Now there is an earth wire connected to the outer metal casing of the electrical appliances, and if there is a current leakage to the metal carrying or the covering, what will happen is there will be a current flow through the earth wire, and due to electromagnetic induction, there will be a current flow through the wire connected to the trip switch. So because of that, immediately the trip switch, the lever will move down and it will cut off the electricity supply to the whole household, so that the consumer is safe from, or the resident is safe from, electric shock. So it is the RCCB or the trip switch. So if we look at the answers, first one, trip switch, that is correct. Main switch, what is the main switch? It is the isolator. Isolator has both main switch and the main fuse. So main fuse does not allow a current more than 30 amperes to pass into the household circuit. So their electricity will be disconnected to the household. And also main switch can be used to turn on and off the electricity supply to the household. Then we have the miniature circuit breaker. Now miniature circuit breaker, if there is a current more than 6 amperes for a lamp circuit or more than 13 amperes for a plug circuit, then the miniature circuit breaker will disconnect the current supply, electricity supply, to a particular part of the household only. So that is the function of a miniature circuit breaker or an MCB. Then you have the electricity meter. Electricity meter records the amount of electric energy that is consumed by the resident. So those are the functions. So the component that protects the residents from electric shock is the trip switch. So I am sure students, so far you have been able to answer all these questions correctly. So with that, we'll move on to the next question. So question number 30. The figure shows so here you can see students, they have given you a figure. Now in that, what can you identify? If you look at the diagram clearly, what can you identify? Now you can see here there is a switch. So there is a switch there. And then what do you see? You can see there are 3 holes. So from that you can identify that it is a plug socket. A plug socket connected to the wall where you can plug in an electrical appliance. And there are 3 pins. So it is a 3-pin plug socket, and from the shape of the holes you know it is for a round pin plug. And from that you know to identify the different pins also that will be inserted into these holes. So here you all know the earth pin will go into this, live pin will go into this, and the neutral pin will go into this. So this is a plug socket with a switch. That is what this component is. So we need to identify the figure. The figure shows the first answer, a single switch. That is is it a single switch? No. If it was a single switch, you will only have a switch. And you all know normally we use that to operate either bulbs or different devices where you need to just switch on the device. That's it. But normally for a light bulb. But here this is not a single switch. Then the second answer, 3-pin plug. Now this is 3-pin, but it is not a plug. It is a plug socket. Here this is a plug socket. If we say plug, what you plug into the socket. So here it is the 3-pin plug socket. So second answer is also incorrect. Third one you can see it is a plug socket. That is correct. Then the fourth one, 2-pin plug. No, again it's not 2-pin and also it's not a plug. So the correct answer is it is a plug socket. So this is a 3-pin plug socket. So here the answer is given as plug socket. So that is how you identify the component from the diagram. You have to look at it, think, and you have to answer. Is that clear, students? So then, I'll move on to the next question. So here you can see extra question 14 of the first extra question. Consider the statements given below. First one, A. All the plug points and bulbs are connected parallelly in the household electric circuit. That is correct, no? Now, normally, we always connect the plug sockets and the bulbs, lights and sockets are connected parallelly in a household circuit. Why is that? You know the reason. You can individually operate each of the light and the plug socket. So, one bulb can be turned on while all the others are turned off. And also, even if there is a problem with one of the devices, say one bulb is burnt off, still you will be able to use all the other light bulbs and the electrical appliances when they are connected parallel. So, that is an advantage, or that is one reason why they connect it parallel. And also, you all know the potential difference. Normally, when it is a parallel connection, potential difference is the same across all the devices or the bulbs. So, that is an advantage of having all the bulbs and plug points connected parallelly. Main reason, you will be able to operate them separately, individually. Is that clear? Then, the second one, B. A person will not get electrocuted when changing the bulb while the switch is turned off. That is also correct, no? Normally, if it is the bathroom, you have to be very careful because it is a wet area. There, you have to be very, very careful. But if it is a normal bulb in a normal place, say the living room or the kitchen area where the place is very dry, then of course, when you switch off the switch, when you off the switch, now you all know the switch is connected to the live wire and electricity flows into the device or the light bulb through the live wire. So, because of that, when you switch off, the electricity supply is disconnected to that particular bulb, and thereafter, even if you remove the bulb, you will not get electrocuted. So, there will be no shock. So, a person will not get electrocuted when changing the bulb while the switch is turned off. So, that is also correct. But students, we have discussed precautionary methods. There you can remember, it is always better when you are doing some repair or change or doing something related to electricity, the circuit, it is always better to wear a rubber slippers or rubber shoes, and also if possible you can wear rubber gloves. But you all have to know that when the switch is turned on, because the switch is connected to the live wire, there is no electricity, no current flowing into the light bulb. So, because of that, you will not get electrocuted. I am sure you all know this by experience also. So, both statements are correct. Now, let's look at the answers. Both A and B are correct. Statement A explains statement B. Is that correct? Now, here this is parallelly connected. That means you can operate the switches individually. The devices can be turned on and off, or the bulbs can be turned on and off individually. That is because of the parallel circuit. But this one is because the switch is connected to the live wire only. Power supply will be cut off, and therefore there will be no electric shock or no electrocution if you change the bulb while the switch is turned off. So, first statement does not explain the second statement. So, both A and B are correct. Statement A explains statement B. That is not correct. Second one, both A and B are correct. Statement A does not explain statement B. That of course is correct. Both A and B are correct, but A does not explain statement B. That is correct. Then third one, only A is true. Fourth one, only B is true. Those two are not correct. So, the correct answer for this one is both A and B are correct. Statement A does not explain statement B. That is the correct answer. Is that clear, student? So, you have to remember, because the switch is connected to the live wire, you turn off the power supply, you cut off the power supply when you turn the switch off, and therefore, it is safe to change the bulb. Is that okay? So I'm sure up to now you would have answered the questions correctly. With that, I will move on to the next question. Question number 50. Isolator can disconnect the. What is an isolator? You can remember it is the main switch with the main fuse. So isolator allows a maximum current of 30 amperes to flow into the household circuit. If it is more than 30 amperes, it cuts off the electricity supply. And it cuts off the electricity supply to the whole household. So, isolator can disconnect the live and neutral wires. That is correct. Because isolator is also a dual pole switch. Isolator, residual current circuit breaker or the trip switch, both are dual pole switches. They are both connected to live and neutral wires, and simultaneously they disconnect the supply to the household by disconnecting both live and neutral wires. So that is why they are dual pole switches. We use that term, dual pole switches. Dual pole switch. Both isolator and RCCB or trip switch. Because you can remember, students, the overload circuit breaker or the service fuse, only the live wire is connected to that. So it disconnects only the live wire. But the isolator and the RCCB, those are dual pole switches. They disconnect both live and neutral wires. So isolator can disconnect the live and neutral wires, live and earth wires, neutral and earth wires, live, neutral and earth wires. Those three are incorrect answers. So you have to remember this related to the components. Is that clear, students? So with that, I'll move on to the next question. So now this is extra question 2. I have completed the MCQ type questions under extra question 1. Extra question 2. First one. Write the energy conversion that takes place in the electric appliances given below. So, you all know that, students, when we use an electric appliance for a particular purpose, electric energy is converted to another form of energy. In some devices, there is just a one-step conversion. Say, for example, electric iron. Electricity is converted to heat energy. But let's say if you take a filament bulb, there what happens? Initially, electricity is converted to heat. Due to the heat, the filament becomes hot and it starts glowing. So, because of that, thereafter it is light energy. So, electric energy, heat energy and then light energy. Same goes for fluorescent bulbs. In fluorescent bulbs, you can remember electricity is converted to UV energy first, UV radiation. And thereafter only you get the light energy. So, there is a first step, there is one energy conversion and then you get the final energy conversion. But in all electrical appliances, you all know all or most of the electrical appliances, there is internal resistance. So, because of internal resistance, there is a certain amount of electricity that is used or wasted as heat energy due to the internal resistance. And you all know conductors like nichrome, which is an alloy of nickel and chromium. They have high resistance. Because of that, they produce more heat. So, usually the electrical appliance where you need to produce heat, like the electrical iron, immersion heater, hot plate, rice cookers, there you can use that particular conductor, nichrome wire coil, so that due to its high resistance, a large amount of heat will be produced. So, that becomes more efficient. But otherwise, due to the internal resistance, if electrical energy is being converted to heat energy, then the efficiency of that electrical appliance decreases. So, these are things that you need to remember related to electrical appliances. But the question is to write the energy conversion. So, here what we will do is we will only write the electric energy and the final energy that you obtain. We don't need to write the intermediate changes taking place, but you have to know that. Now, filament bulb, like I told you all, initially electricity becomes heat energy, then only light energy. But here, if we write light energy, that is fine. So, write the energy conversion. So, since they say energy conversion, it is better to write as electricity to light, or electric energy to light energy. Then electric ion, electric energy to heat energy. So here electric energy to heat energy. Then television. What happens there? You hear the sound and also you see the movie or the whatever program that you are watching. So there it is both light and sound energy. So electricity to light and sound. Both forms of energy in television. Then electric motor. Now electric motor, the motor rotates. Usually there is a motor connected to a fan or just the motor. There it is the rotation of the motor. So then it is kinetic energy. When there is rotation, movement, there is kinetic energy. So electricity to kinetic energy. And then finally radio. Radio, of course, you don't see anything, you only hear the sound. So electric energy to sound energy. That is in radio. So those are the energy conversions. Write the energy conversion that takes place in the electric appliances given below. Filament bulb, electricity to light. Electric ion, electric energy to heat energy. Television, electricity to light and sound. Electric motor, electricity to kinetic energy. Radio, electric energy to sound energy. Here, since we are writing many appliances, we have to repeat electricity again and again. But when you are answering a normal question for your paper, there will be just one conversion. So it is better to always write electric energy to sound energy or electricity to sound and light. Like that, give the full energy conversion. So I'm sure you will be able to do that, students. With that, I'll move on to the next question. Extra question 3. First one, what is known as power of an electric appliance? There are two definitions, or basically they mean the same thing. Power is the work done in a unit time, or the electric energy consumed in a unit time. So we can write both the definitions. So here I will say power is the work done in a unit time, or the electric energy consumed in a unit time. And you all know the equation for power. Power is equal to voltage into current. P equals VI. And the SI unit of power is watts. WATTS, watts. And the symbol is capital W. So that is power. The unit, symbol of the unit is capital W. So then, second one, When a filament bulb is connected across a voltage difference of 6 volts, a current of 3 amperes flows through it. What is the power of the bulb? So, you know the value 6 volts and 3 amperes. So, to find the power, what is the equation? Power equals voltage into current. That is P equals VI. Now students, when you are writing the answer, you don't have to write the equation in words as well as in symbols. You can just write the equation in symbols. But for you all to recall what you have learned, I am writing both. So if you just write this step and continue, that is more than enough. So here, voltage 6 volts into current 3 amperes. So that is 6 into 3, 18 watts. Volts into amperes, the unit of power is watts. 18 watts of power. So when a filament bulb is connected across a voltage difference of 6 volts, the current of 3 amperes flows through it. What is the power of the bulb? Power is equal to voltage into current, that is P equals V into I, and that is given by 6 volts into 3 amperes, that is 18 watts. I am sure you got that answer correctly. So with that students, I will finish this chapter, and in the next chapter also, I will continue with some more extra questions.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.